So, I think everyone is not here. I will start it. Yeah. High precision localization services. Service with precision and localization. That is very important. So, applications indoor navigation, automated warehousing, smart retail, augmented navigation. I think all you are familiar with augmentation. Very good. बच्चा नहीं ऐसा तबीयत खराब हो गया था आ जाएगा Key features is localization accuracy less than 1 centimeter. I would like to see less than 1 millimeter. But maybe some other G will come. Do you think any other G will come after 6G? Do you think so? Works in GPS denied environments like indoor, underground, tunnels, and so on. Examples are hospital navigation, automated warehousing, detailed personalization, their location-based AR promotions and directions inside stores. These are the possibilities. Oh, that's very good. After one slide, takeaway. That's good. You want to ask something? No. Takeaways. That's very good news. Takeaway means the course is over. What do you think? Take over. Okay. So understand how 6G KPIs directly support emerging and extreme use cases, including real-time, high-risk, and immersive applications. Differentiate between the core 6G service categories. I think you are familiar. You are LLC, ultra reliable, low latency communication, EMBB, enhanced mobile broadband plus, MTC, massive machine type communication plus. Explain the role of energy efficiency in sustainable low power networks, localization accuracy in a smart environment, and automation. It says explain the role of. Who can explain? Role of energy efficiency in sustainable low power networks. Leave it. Let us go ahead. Identify real world 6G application scenarios that demand extreme reliability, ultra fast data rates, and sub millisecond latency. That is what I was talking about. Remote surgery, holographic meetings, autonomous vehicles, smart grids, and precision farming. So you can see in farming also 6G will play a very significant role. Lecture 1 is over very fast. Lecture 2 relates 6G terahertz spectrum band challenges and opportunities. So perhaps it will talk about more spectrum and terahertz range. Why do we need terahertz? Why not gigahertz? We keep it or millihertz. Why we are going so far? Any point to discuss here?
Requirement of bandwidth for higher data rates.
That creates the problem. Go for low data rate then. So, as 5G matures, the demand for ultra high data rates, ultra low latency, and massive device connectivity is accelerating. 6G aims to fulfill data rate going to 1 terabit per second, latency under 100 microseconds, 3D positioning with centimeter level accuracy. I want millimeter. To meet these targets, spectrum expansion beyond 100 gigahertz is essential. Terahertz range, frequency band 0, 1 to 10 terahertz, falls between millimeter waves and infrared light, known as the terahertz gap, now turning into a strategic asset for 6G. So this spectrum becomes so important, the word has been used as strategic asset. We say asset when we have diamond, platinum, gold in the house. Here, asset is terahertz. That is the asset they are talking about. How many would like to sell your platinum and diamond in the house to terahertz? Do you want to sell diamond jewelry of your wife to terahertz? Suppose I give you 1 terahertz, you will give me all diamond platinum of your house. Understand that terahertz frequency range features lies between millimeter wave and infrared. Still, I am waiting Arun so that he gives the last talk. Anybody who can tell me, should I expect Professor Arun here in few hours? I don't want to say few minutes. That is out of question. We have about 1.5 hours from now to finish the lecture. He will come. I assure you, he will come. Perhaps he is looking in the Oxford Dictionary, the meaning of Arun. And both are out, Arun and then Devendra is also out. So he is trying to understand Dev plus Indra is Devendra. How far he can go beyond that. And then my Bangladesh colleague is not here. Huh? Only one is here. One represents everyone in Bangladesh, including the new Prime Minister. So you are the most powerful man of the world. ये दोनों कहाँ से आ गया घूमते हुए? कहाँ घूम रहे थे? He was sleeping. I know what he was doing. I will tell you when I am alone. I will tell you what we were doing. Okay. So, yeah, lies between millimeter wave and infrared, offers a spectrum abundance, thousands of gigahertz of bandwidth, enables high density, ultra fast wireless personal area network. Personal area network. You know what is the short form of personal area network? पान. कितने लोग पान खाते हो? पर्सनल एरिया नेटवर्क PAN पान. पान खा लो, काम खत्म हो गया. पान मिलता है यहाँ पान बहुत मिलता है. अब बहुत लोग खाते हैं. तुम लोग खाते हो पान? कभी कभी. तो बंगाल को तो हर बंगाली पान खाता है. यदि पान नहीं खाएगा तो बंगाली कहलाएगा ही नहीं, है नहीं. और कहाँ का पान सबसे अच्छा होता है? बेस्ट पान ऑफ द वर्ल्ड. नेचुरली तुम बोलोगे बांग्लादेश का. ये बोलेगा बंगाल का. हाँ, बनारस. वो कौन गाना गाएगा बनारस का? वो अमिताभ बच्चन गाया था. कौन पिक्चर में? कौन सा पिक्चर था? हाँ हाँ, तो गाना कौन सुनाएगा? पान वाला गाना को जानता है? यू नो द पान. अमिताभ बच्चन पान का गाना गाया था. सुनाओगे क्या? ये जानता है? ही इज फ्रॉम बनारस. मुझे गाना गाता है कि नहीं? कौन बोलो? वो गाना सुनाएगा. ओके, पहले तुम बता रहा है. नहीं, बनारस का गाना सुन लेना है. मोदी जी बनारस जाते हैं बहुत. उनका इलेक्शन क्षेत्र वही है और वहीं से प्राइम मिनिस्टर बन के जाते हैं. बनारस का गाना सुना रहे, तुम भी प्राइम मिनिस्टर बन जाओ मोदी जी के बाद. तो कौन आ रहा है बनारस का गाना? पान क्या गाना था, याद है? हाँ, कौन गा रहा है पान का? गा रहा है या गा रहे जो भी हो. वो चलो पान. बहुत तेज लड़का है, शार्पेस्ट. लास्ट गाना वही सुनाया था ना. लास्ट सॉन्ग वही सुनाया था. देखिए, ये गाना का इंतजाम कर रहे हैं आपके लिए. आपको थक गए होंगे लेक्चर सुनते. गाना सुन लीजिए आप भी, अच्छा लगेगा. आजा बालक. दो उसको पहनाओ. ये मेरा पहना दोगे? बैठिए।
अरे भांग के रंग जमा हो चकाचक, फिर लो पान चबाए।
Come into action like Amitabh.
अरे ऐसा झटका लगे जिया पे, पुनर्जन्म हो जाए। ओ खाई के पान बनारस वाला, ओ खाई के पान बनारस वाला, खुल जाए बंद अकल का ताला। ओ खाई के पान बनारस वाला, खुल जाए बंद अकल का ताला। फिर तो ऐसा करे धमाल, सीधी कर दे सबकी चाल। ओ छोरा गंगा किनारे वाला, ओ छोरा गंगा किनारे वाला। अरे राम धुआई कैसे चक्कर में पड़ गया, हाय हाय हाय। कहाँ पान जान फसाई, मैं तो सूली पे चढ़ गया, हाय हाय हाय। मैं कैसा सीधा साधा, मैं कैसा बोला भाला, हाँ। अरे कैसा सीधा साधा, मैं कैसा भोला भाला। जाने कौन घड़ी में पड़ गया, पढ़ो लिखो से पाला। मीठी छुरी से हुआ हलाल, छोरा गंगा किनारे वाला।
वेरी गुड। अमिताभ बच्चन को इन्फॉर्म कर देंगे हम। ओके, छोरा बनारस वाला। तो बनारस में मोदी इसलिए जाते हैं, समझे नहीं? इलेक्शन जीत के आते हैं, प्राइम मिनिस्टर बन जाते हैं, और नेक्स्ट प्राइम मिनिस्टर हमारा वही होगा। So frequency range is 0.1 to 10 terahertz, wavelength 30 micrometer to 3 millimeter, common use, imaging, sensing, and soon, of course, mobile 6G. What are the advantages of terahertz? Terabit data rates. Terahertz bands offer tens of gigahertz bandwidth. That's very important. Enabling wireless transmission at hundreds of giga to terabit per second. This is the first point. Second point comes as a high resolution sensing and imaging used in radar, medical diagnostics, and material inspection. Particularly when, if you go through X-ray and systems, there you need it. 6 gigahertz can integrate communication and sensing, example, AR, remote surgery. So that's a plus point. 3D positioning and pencil beams, sharp directional beams, and useful in factory robotics, drone control. Somebody was talking about drone. All of you like drone, I think. Then near zero delay, AR, NR, XR, and holography need real-time 3D feedback. Terahertz enables sub-millisecond latency with massive data throughput. So these are the plus point we have. It is equivalent to 3 slides. And you have many slides like this. How many slides are left now? 38. 30. And I have time 1.5 hours. And if Arun comes, I will give him half an hour. If he does not come, then I have to continue. Or he will give a talk. Who else will give the talk other than me in a classroom? Anybody who has left? Oh, yes. You have given already? Which year? 2023. I think who can be the best? I think that girl sitting at the end, she was the best one to give a talk. You have given already? Which year? She has given a talk?
No, sir.
No, sir. No, sir. So I give you half an hour to think, and after half an hour, I will request you to come to the stage. Just you decide what you want to talk. Either sing a song. Song means 3 songs. मजा आएगा ना 3 गाना सुनने में, अच्छा लगेगा. हाँ. और नहीं तो भाषण देंगे. आप गलती से आ गए क्या?
नहीं सर, मैं आपको बोला था सर, आपकी परमिशन से 20 मिनट लेट हुआ.
और अरुण कहाँ गया? वरुण मर गया. उसको लेक्चर देना था अरुण को आज. मीटिंग है. मीटिंग इम्पोर्टेंट है, वर्कशॉप इम्पोर्टेंट है. वो नहीं आएगा. व्हाट्सएप मैसेज भेजो कि सर एंजॉय कर रहे हैं. फोन करो. तो बोलेगा फोन उठाएगा नहीं. So this slide is equal to 3 slides. So I will take 3 seconds to finish it. So terahertz spectrum landscape and regulatory overview. So about regulatory issues, FCC, as I told you, FCC, American, ITU, of course, international, and ITP is also international. So FCC allocated 95 gigahertz to 3 terahertz for experimentation. Unlicensed use, released 20.2 gigahertz for commercial and R&D activity. So at least it's good for you also, you can do research. आप शॉर्ट बदल लिए क्या? हमको भी बदलना चाहिए था. ये दिखाई पड़ा कि it was not what you were having in the morning. आँख तेज है.
Morning I came at 8 a.m. It was cold at that time. Now it is very hot.
यहाँ कोल्ड कब होता है?
Sir, December, January.
नहीं, आज की बात कर रहे हैं.
Morning में थोड़ा सा before it.
Do you agree with him? मॉर्निंग में कोल्ड होता है. एग्री नहीं कर रहे हैं वो.
Sir, it depends. Like, for me, one temperature may be good. For others, it may not be good.
You know, this is called an argument.
Providing my justification.
This is called an argument. And the professor knows very good argument. That is the feature of a good professor. तुम भी अच्छा प्रोफेसर हो. बच्चे बताएंगे. ठीक है, किससे पूछा? Has he taught you? He is your teacher? No. Any student is your professor? Oh, अच्छा टीचर है ये. क्यों अच्छा कहते हो? क्यों अच्छा? Why do you say he is a good teacher? सुपर एक्सेलेंट है. नहीं, आज तो तुमको 0 मिल गया. ठीक है. So we were discussing about regulatory milestone. Of course, FCC is important, ITU is important, ITP is important. They decide frequency. So FCC has decided release किया 21.2 gigahertz. ITU, that's the most important. So it is 275 gigahertz, and ITP 252 to 325 gigahertz. Band allocation reference. This table shows the band. So it is fixed 55.54. It is in percentage, it is not number. Mobile 55.54 fixed in mobile is almost same. Earth 33.60 is space research. Who want to do a space research? Anybody wants? I think girls like to talk much. Whenever I turn their face, I see girls are talking and boys listening. You enjoy talking? Can you give a lecture on talking? That can be a good subject, talking. Think over it. I will request you come to the stage and give a short lecture on talking. जब भी फेस चेंज करते हैं ना, दोनों बात करते रहती है, वो बड़ा ध्यान से सुनते रहता है, बीच में एक शब्द जरूर बोलता है वो, ये भी ध्यान पड़ जाता है मेरा। हाँ, गौरव तो गौरव ही है। और ये लड़की नेहा है, अब बीच में वो लड़की अपना नाम नहीं बताती है। नेहा बोल दी, तुम बोलोगी, वो लड़की जो पीछे वाली है वो बोल दी, हम बोल दिए हैं। इंडिया के लोग झूठ बोलने में बहुत तेज, लेकिन इतना झूठ बोलेगी हमको विश्वास नहीं था। मतलब कि समझ गया कि बुढ़ा प्रोफेसर तो भूल गया होगा, मैं बोल दूं कि बोल दिया है मैंने, छोड़ूंगा नहीं। दोनों आमने सामने बैठे हो, दोनों को बोलवा के रहेंगे। सोच के रखो, बड़ा आसान से बोल दी, हम बोल चुके हैं। नहीं, तुम्हारी गलती है, तुम्हारा स्टूडेंट लोग झूठ बोलता है। अब पता नहीं तुम, हाँ, अब पता नहीं तुम कितना झूठ बोलते हो हमसे। जब स्टूडेंट झूठ बोलती है, वो लड़की होकर, लड़की लोग जल्दी झूठ नहीं बोलती है प्रोफेसर से, और हमसे झूठ बोल दी, ये पता नहीं कितना झूठ बोला होगा अभी तक। बी क्लियर और ऑनेस्ट, कितना झूठ बोल चुके हो। आज तो तुम खिला रहे हो, कल तो खाना खिलाएगा ही नहीं, कल कोई नहीं बुलाया हमको है। तो होस्ट पर डिपेंड करते हैं, हो सकता है भूखा ही विदा कर दे परसों हमको। नहीं, विदा ही नहीं करे, आए ही नहीं होटल में, तो कार तो मिलेगा नहीं, टैक्सी कैसे खो जाता है यहाँ, ये भी नहीं पता हमको है। तो तुम्हारे डायरेक्टर का नंबर है, उनको कॉल करेंगे, तो ड्राइवर को भेजेंगे, या खुद ही कार ड्राइव करते हैं, खुद ही। दिखा नहीं है। अब तो वही सहारा हमारे हैं एयरपोर्ट जाने का। बेटर एक आज ही फोन करके बता देंगे उनको कि आपका प्रोफेसर तो बेकार निकला। ठीक है, लड़की तो झूठ बोली, प्रोफेसर भी झूठ बोला, हो सकता है डायरेक्टर महा झूठा हो। इंडिया में कहानी है, यू नो, इंडिया में कहानी है कि गांव का मुखिया, समझते हो ना, ग्राम पंचायत का मुखिया होता है, तो मुखिया झूठा होता है, झूठ बोलता है, फिर गांव से फिर एमएलए बनता है, वो मुखिया ज्यादा झूठ बोलता है, समझे। तो फिर कैबिनेट में गया तो चीफ मिनिस्टर बना, चीफ मिनिस्टर एमएलए ज्यादा झूठ बोलता है, फिर पार्लियामेंट में गए तो एमपी उससे ज्यादा झूठ बोलता है, एमपी से बड़ा कौन हुआ, प्राइम मिनिस्टर, इंडिया का महा झूठा आदमी होता है। स्टार्ट हुआ मुखिया से, चला गया प्राइम मिनिस्टर, मुखिया झूठ बोला लेकिन मिनिमम झूठ बोला, और प्राइम मिनिस्टर महा झूठा है। ये इंडिया का कहावत है। सब रिकॉर्ड कर रहे हो ना लेकिन सही बात बता रहे हैं कि झूठ कैसे बोला जाता है इंडिया में। स्टार्टिंग फ्रॉम मुखिया टू प्राइम मिनिस्टर, रैंकिंग गोज अप एंड अप एंड अप एंड अप। जितना बड़ा झूठ बोलो उतना बड़ा आदमी बन जाओगे। तो तुम चाहते हो कि इंडिया का बड़ा आदमी बने, तो झूठ बोलना स्टार्ट कर दो अभी से। तुम लोग को ऐसा हो झूठ नहीं बोले हो, एनीवन हु हैज नेवर लाइड। ये गलत क्वेश्चन हो गया, नहीं, गलत क्वेश्चन हो गया। एग्री करते हो? झूठ बोलेगा, क्यों? झूठ क्यों बोलेगा? वाई? क्यों बोलेगा? क्यों बोलेगा? हम जाके बोले बाहर में क्लास नहीं लिए, क्यों क्यों बोलेगा? दैट इज व्हाट आई वांट टू नो। व्हाट इज मजबूरी, क्यों? व्हाट इज द पर्पस ऑफ टेलिंग लाई? व्हाट इज द पर्पस ऑफ टेलिंग लाई? अब तो यदि झूठ बोलोगे तो कहावत है, हाँ, झूठ बोले कौवा काटे। पूरा गाना याद है?
लेकिन ये झूठ नहीं है, सच है। लिरिक्स वगैरह याद है।
चलो, झूठ स्टार्ट हो गया यहीं पर से। कैसे नहीं है कि याद तो होगा रघुपति राघव राजा राम पतित पावन सीताराम, जानते होगे, कभी बोले नहीं हो? नहीं, रघुपति राघव राजा राम लिरिक्स से क्या मतलब है? कोई लिरिक्स से मतलब नहीं है, झूठ यहीं पर बोल दिया। चले, बच्चे लोग आ रहे हैं धीरे धीरे, नंबर बढ़ते जा रहा है। एग्जाम आज है क्या? कल? आज नहीं एग्जाम है? बहुत सी रिकॉर्डिंग की वो सबको डिलीट भी करना शुरू कर दीजिएगा। हाँ, so we were talking about the table. Percentage wise allocations, we talk inter-satellite 20.13, fixed satellite 20, mobile satellite 19.26, and so on. So I don't think I will read all. You can look at, there are 13 frequency allocation. Key enablers. So one is compact and tunable, improve and reduce loss. Second is photonics, generate and detect high frequency waves using optical. जान से गर्दन गर्दन घुमाया है। इस बार दोनों लड़की लोग बात नहीं कर रही है, एकदम नहीं बात कर रही है, और लड़का सुनने की कोशिश कर रहा है, लेकिन विस्पर भी नहीं कर रही है दोनों। कोई नहीं बात कर रहा है। ओके, RF front end design, and last sentence is this technology supports sharp directional pencil beams with minimal interference and high localization accuracy. This diagram is good, and the diagram is 11.5 from the book figure, I think. The challenges in terahertz communication. Till now you have seen the applications, advantage. Then it is talking about what is the challenge we have. It is not easy. Free space loss is proportional to frequency. So what will happen? Do you think we'll have the more free loss or less free loss? High loss. High loss. So more and more frequency, higher and higher we go, we are having the more loss. It requires ultra-massive MIMO and beam forming for compensation. It means more effect, more impact, and more expensive also. Atmospheric aspects, oxygen and water vapor cause frequency selective attenuation. 60 gigahertz above we go, this problem we face. But why we want to go high frequency? What is the purpose? Why do we want to go millimeter wavelength and so on? Any idea?
To utilize more bandwidth, to increase data rate.
And this is good answer. But one important point, what coming to my head at the moment, perhaps those frequencies have not been used earlier for wireless communication application. They are freely available. Yeah, that's the plus point. So government will easily allocate the frequency if any operator goes to ask. So transparent spectrum windows are 100 to 115 gigahertz, 125 to 170, 200 to 150, and refer figure 11.5. That is right hand for absorption peaks, where we are getting the more one, like we are getting absorption here, here, here. These are the frequency we are getting the more loss. Then last point is component limitation, inefficient, power hungry. People are hungry sometimes for the food, but they are hungry for the power. And the power, if you are the Prime Minister, you would like to control the whole country, so power hungry. The Prime Minister is the most power hungry person in the world. Phase noise in mixers and oscillators. heat dissipation in cheap scale models. So, what are the use cases? Digital twins, mobile holography, real-time AR, VR, wireless backhauls. Then they have given the requirement for digital twins less than 1 millisecond latency, 0.8 terabit per second, mobile holography, 0.58 terabit per second, XR, real-time, 0.9 gigabit per second, sub-millisecond delay, wireless backhaul, multi-gigabit per second, ultra narrow beam. Okay, this is very important slide. Use cases insights. So real-time AR, VR, and they are talking about the challenges and advantage. Digital twins, again application, stream high-resolution sensor data, and maintain synchronization between the physical and digital models. Mobile holography requirements mentioned here. Then terahertz roll. Then wireless backhauls. Backhaul everybody knows, I think. Challenge fiber deployment is expensive in dense urban remote areas. Why it is expensive fiber deployment? Anybody can tell me? Fiber deployment is very expensive in urban and dense area. What can be the reason?
Because we need to
Little louder.
with like suppose we want to connect with the fiber cable to any one particular location from the hub, we need some kind of proper management, and we need to disturb the existing infrastructure. For example, if road has already been constructed, we need to like cut it down, and then we need to disturb the traffic. So instead of going with the fiber based this broadband, nowadays people are preferring this wireless broadband. So one antenna can be placed on top of one building, and this antenna will be responsible to provide you the beam form, like I just forgot the exact name, but through that beam, signal will be directly transmitted to your home's antenna, and then you can get the wireless connectivity with that particular receiver. So it is very flexible, and within say 1 hour, 2 hour, you will have your wireless broadband. For fiber based broadband, you may take like the system may take around 10 to 15 days for the
Right.
deployment. So
Very
But the
good.
thing is that in case of fiber, if there's any cut or anything in the fiber, obviously it takes time to replace that because you need because it's a glass basically. The fiber is made up of glass core and cladding. So obviously you need to if you have to replace that, it would take some time until and unless then you have to join the glass fiber, so which requires some time. As sir said, if it is wirelessly done, obviously that even if there is a damage in the wireless setup, so it would not take much time to replace that or to rectify that issue. So that's why wireless uh, technology at this moment would be much more of an advantage.
Very good. Okay. So we were talking about a fiber terahertz solution, narrow pencil beams for interference-free links used between rooftop, small cells, or drones and core network gateway. Why they are going to rooftop?
for always
Last one.
For good line of sight connectivity.
Would line of anything else? Line of sight. Technical enablers for these use cases. 1, 2, 3, 4. As usual, 4 points are there. 3D tabulation and beam forming using material and no, somehow I'm mathematician, so I'm reading mathematics. It is not mathematics. It is metamaterial antennas, high resolution sensing for gesture, voice, and environmental feedback, terahertz compatibility, and then hyper-immersive learning environment to real-time control. These are the points. Deployment, and this is the real tough task we have in technology. Indoor small cells, terahertz cells with few meter range, ideal for offices and so on. So terahertz application, why it is ideal for offices? Anyone can tell me a few points? It's ideal for offices, stadium and so on. Why?
Maybe because short range communications, mostly indoor.
Mostly indoor, yeah.
That's why it is ideal.
Line of sight dominance, terahertz struggles with obstacles. Quite natural. This is the biggest problem we have with terahertz. A smart antenna steering, this is another problem. Real-time alignment, critical for mobility. Long-range coverage still relies on millimeter wave, optical fiber, and satellite navigation. Complete hybrid mode. Then factor range. They are talking about terahertz. Few meters ideal for indoor, short distance use cases. Obstruction highly sensitive, requires line of sight or use of intelligent surfaces. Mobility demands real time, and then integration is required. Deployment considerations. These are the point which we have to consider for the deployment. A small cell indoor communication. I think whether I don't know if you have remember if you have studied macro cell, micro cell, pico cell, hmm? Femto cell. But now people are not using it. No, it has gone with the wind.
Even people are proposing cell-free
Self-free, yes.
Cell free. But the days of those things have gone. Macro, micro, pico, femto.
because when we have cells, we need to make the channel allocation.
Mm.
That is actually a very hectic process.
Mm.
So when we don't have cell kind of structure, whatever the resources in terms of channel we have, we can dynamically allocate.
That's
So
true. Yeah.
that is the plus point.
So a small cells, the point they are talking about description, deployment, common use, key advantage. What is the key advantage of a small cell? Offers ultra high throughput. Throughput, everybody knows the definition of throughput. Can you define throughput? That is a word very common in wireless. Who can define throughput? Anyone raise your hand? What is the meaning of throughput? Yeah.
Number of successful bit transmitted per bit.
What did you say?
Number of successful bit transmitted
Hmm.
per channel or per bit.
That's the correct answer. So throughput is very important parameter. Two parameters very important: throughput and delay. Delay should be minimum. Throughput should be as high as possible. These are two important points. Applications: corporate offices with heavy cloud processing, hospitals, stadium, concert venue, all these small areas, they are very important. Deployment, ideal for indoor environments where control over signal path is possible. Line of sight. Do you understand the meaning of line of sight? Everybody understand line of sight? Challenge, terahertz communication is strongly line of sight dependent due to scattering losses from walls, furniture, and people. Inability to penetrate most solids and liquids. But line of sight, it is a requirement. And then even, for example, this is there, this will create the problem. Inability to penetrate that we talked. Implication, any blockage, even by human body, can cause signal loss. So if we are transmitting, and if, suppose, for example, some receiver is here, transmitter is there, and I am standing in between, that also causes the problem. Requires clear line of sight and minimal interference zones. Mitigation, deployment in open layout spaces, reflective surfaces, and intelligent reconfigurable surface to bounce signals. So dense small cell placement to ensure overlapping coverage zones. So this is another demand we have. A smart antenna is steering. A smart antenna. Which antenna I will call a smart?
That can have some kind of intelligence to adjust the phases and amplitude of the
Hmm.
signal, so that we can have the maximum coverage in the intended direction.
Okay.
Like for example, we have a location like a user which is situated at one particular location, and if that user is moving,
Hmm.
that antenna, based on the movement, antenna should be able to adjust its beam as per the movement of the user in order to provide the better reliability and that may be considered as.
Everybody listens to him. I don't. People didn't listen to you. Can you say a little louder? Yeah. I think they didn't listen to you.
In my opinion, smart antenna can be considered as antenna which has some kind of intelligence. Based on its intelligence, like in one particular scenario, if say transmitter is transmitting something to one user, which is just say one at one particular location. So based on one particular location, it is adjusting its phase and frequency and amplitude. If the user is moving from one location to another location, the antenna should be capable enough to detect the motion, and accordingly it needs to change the parameters so that the continuity can be maintained in terms of the reliable link as well as the required throughput at the receiver side. Yes. Yes, this is the concept that is nowadays applicable in 5G scenario. So, like there is always a limit. If user is moving below that certain limit, then we can actually provide the connectivity using directional beamforming, and based on the user location, the actually we will have multiple antenna arrays in 5G base stations. So based on the parameters, antenna parameters, we can actually provide beam forming accurately, and that beam can follow the movement of the user. So if the user movement is restricted to some limit, of course we can provide directional beam forming. So all, like suppose we have say in massive MIMO, suppose we have 128 number of antennas. Okay, so one group of array of antennas will be at a time providing services, and if user is moving one like set, that set of antennas may contain the like may continue the transmission, or in other cases like when movement of the user is beyond the limit, then number of antennas will be changed, and accordingly beam forming will be done. That's the thing.
Clear? Yeah. So techniques are electronically steerable phased arrays, then metamaterial antennas that redirect beams in nanoseconds, then AI assisted. What are the consequences? Sudden drops in connectivity due to beam misdirection, and requires real-time feedback loops to adjust beam angles continuously. So this is the really tough task. Long-range coverage with hybrid architectures. Due to range in penetration limit, triage cannot be a stand-alone wide area solution. So we have to go for hybrid. It is not possible to just one system that can work. Complementary technology then millimeter wave, 30 to 100 gigahertz is still viable for 100, 500-meter coverage. Optical fiber, as we mentioned, or LEO satellite. Deployment, use terahertz for high-speed indoor or last-meter access. Use millimeter wave for last-mile delivery. Use fiber and satellite for core and backbone transport. So fiber and satellite only for core network. Real will be all millimeter wireless. Roadmap 21-23, vision setting, global coordination. Still we are before 26. Experimental trials, test beds, transceiver development going on. 27-29, pre-standardization and regional spectrum trials. So for standardization, one has to go for trial. System is developed, for example, Indian Ministry of Communication, they will do one trial, US will do one trial, Europe will do one trial, and so on, and then there will be meeting in ITU, go for standardization. So 2030, large-scale telehealth rollout in ultra-range zones. So this is a time plan, what we have, and already we are in 25, and we are going ahead with experimental trial. I don't know if India is doing experimental trial. Not yet. Not yet.
So because we are not yet fully received 5G technology.
Okay.
So we are just like looking forward to get 5G first,
Hmm.
and then we can start 6G trials.
Do we have 5G all over the country?
No, sir.
No, but my mobile phone is 4G or 5G. I cannot say it. It is nothing is written. Generally in Denmark, I find it in 5G.
Yes, sir. Here at some places we can get signal of 5G, and other places we are still relying on 4G.
Okay. Denmark was the first country in the world which deployed 5G, and then of course many countries followed.
Sir, just I have one question. A large scale, like after 2030, we will have large scale terahertz rollout. So it will be like this particular technology will be
Deployed.
deployed
Hmm.
by the cellular service providers, or like who will be the service providers?
Very good question. Actually, service provider will be different this time because frequency will be sold out.
Yes.
And suppose you buy, so it is you who will roll out. Your company will, you means your company will roll out. So like we had a 3G, 2G, we had a really service provider. Here service provider question does not arise because we don't have cellular network. So just spectrum and application.
So
So just
any individual or the owner of one
company, yeah.
company or maybe warehouse or
Yeah, something like
factory,
that.
they can
Even
get the
individually, if I have the money myself, because naturally I have to finally launch a company. But if I have $1 billion, I can take it. If I see that it is a good profit, at least the good friend of Trump, he will buy a whole world frequency. He is very smart man, and perhaps he is going ahead with this system to earn more and more because he wants to maintain his richness in the world. So anybody can buy if you have the money.
so
It is not a question of company.
isn't such a frequency of very damaging to the environment? Like, is it not harming to us in some way? Or
Can you reply him?
whatever the frequency that we will be using for this 5G or 6G, it will be under the non-radiating category. So when we say non-radiating, it will not impact on human or animal body. That is the when any frequency is radiating, then it can harm your body. That's the basic.
So take away. Somehow my student has put take away many places. So again, she is talking about take away. So ideal for high density, high speed, short range zones, a complement to millimeter wave, sub 6 gigahertz whales in satellite. Future research direction. I think all of you are young researchers. Think about research. Think about PhD topic. Hybrid terahertz RF systems, beam tracking and prediction algorithm on chip terahertz generation and detection. Terahertz will reshape mobile wireless communication. This is a good challenge as we know it with near fiber speeds over air. Do you want to say a few words on this sentence?
So last one.
Last sentence, yeah.
So actually, whatever the facilities we have with fiber communication, basically it can provide like the data rate in terms of Gbps, gigabit per second. and reliability will be much higher than the wireless communication. So what we are basically doing with wireless, we are just trying our best to match whatever we are getting with the 5G. So with this 6G, we are first improving the data rate using terahertz communication. We have a full bandwidth and we can utilize bandwidth and to increase the throughput, maximum throughput that we can have. And along with that, we are also focusing on the reliability. This
That's
is the
important.
major concern in any wireless communication. So our target is to achieve what we can get through the fiber. That's what the meaning of this statement is.
Yeah, right. So we start lesson 3 or give a break? Break. Or 10 minutes is okay? 10 minutes short break. कितना लेक्चर है? लेसन 5 है क्या?